Y'all ready for math? Y'all ready for math? Welcome back to another Math 11 Honors, Pre-Calculus Honors, quarantine math lesson by Mr. Berto, okay? And this is optimization day 6, star. I know I haven't been writing those types of topic sentences because we've really just been doing the same thing with different types of problems, but it's optimization. Day 6, quarantine, day 500 it feels like, okay? You know, optimization day 6 here. Looking at those homework problems, you had to do a calculator solution on both of them. Number 3 was a little weird from the packet. You know, find two positive numbers, x and y. They're telling you what they are, such that their sum is 35 and the product x squared y to the 5th is a maximum. Okay, so look, that's a weird product. There are different types of products, okay? It's not always just, you know, a number times another. It may be a number squared times a number to the 5th power. So you want to maximize that product x squared y to the 5th. Got to get an equation for that thing. They give it to you. Okay, I said P equals. You could say whatever you want equals. You can't say a number, though, because you don't know what it's equal to. You want to actually maximize this product. Make sure you get it down to one variable. They told you if the sum of the two numbers is 35, then it should be pretty easy to get down to one variable. Really annoying to do a calculus solution here. Excuse me. You have a little product rule action with a chain rule inside of it. It's doable. You could play around with that if you want to. As far as the domain, x and y are both positive numbers, so x has got to be greater than 0. It has to be less than 35, because if x is equal to 35, then y is actually going to be equal to 0. So look, you want to graph that thing in the calculator. You know, it's, you know, don't really know what x is equal to, but you know it's got to be, you know, bigger than 35 because x plus y is 35. Less than 35. But if you make 35 the upper element of the domain, maybe you get a decent picture here. Just remember, calculator solution, I need to see an equation for what you want to maximize and minimize in one variable. I need to see a domain. I need to see a sketch. Sketch! I need to see axes labeled. And you better calculate that maximum or that minimum point. This number right here is insane. What is this number? That's actually the p-value. That's the maximum product. Yeah, if you take numbers, you square them, and then you raise another number to the 5th, and you multiply them, you get big numbers back. They never wanted that product. They just wanted to know the two positive numbers that guarantee that maximum product. We know we have a maximum x is equal to 10 right here, and then that means that y is equal to 25. It's not really a terrible problem. Just like number one and the other ditto that was handed out, and we're going to do number 2 today, and then we'll call it a day. The sum of two positive numbers is 96. The year I was in 11th grade, just like many of you. What is the minimum, not 1896, that's when Harrington was in 11th grade. What is the minimum value of the sum of their squares? People are like, well, we have two positive numbers. I'll call them A and B. People are like, well, I know I want to minimize the sum of their squares. Well, how do I minimize the sum of their squares? Well, you just take two squares, and you add them together. And that's the sum of their squares. I'm just kidding, okay? But that kind of looks like a guy with like glasses, right? A pair of glasses. Now they look really cool. Now they're sunglasses. Anyway, so the idea is that, look, you want to minimize the sum of the squares of the two numbers. People are like, what's the sum of their squares? Well, you square them and you sum them, okay? So a squared plus b squared. Get it down to one variable. We know a plus b is 96. Get that domain, okay? And when you graph this, just be careful. Do the best you can to find this minimum here. Then you're going to have to readjust the viewing window, okay, and make the y min equal to 0. Remember, this is the a-axis in this particular problem. This is now the s-axis. Make sure you label those. This 48 is an a value. So it's actually what one of the numbers needs to be for the sum of their squares to be a minimum. This right here is that actual sum of their squares that you're looking at, 4,608, or the year I plan to live to, 4608. Anyway, and then you can go right to the answer. You don't got to draw a line or write up a blurb because it's a calculator solution. We'll do another calculator solution problem here to finish things up. So go to that ditto that you had number 1 from, for homework, the sum of their squares one. And let's do number 2, a cylindrical container with an open top is to have a volume of 64 pi cubic inches. What is the minimum surface area of the container? People start freaking out. They're like, it's a cylinder. Everybody, but just relax, okay? First, figure out what to maximize or minimize. Well, you know you want to minimize surface area. Then people are like, what do I do now? Well, in your best American Italian, you gotta get an equation for that thing. You gotta put in the hand gestures there. Hey, I gotta get an equation for that thing. Mama, Joey, I gotta get an equation for that thing over here. And what thing is that? Surface area. And people are like, surface area of a cylindrical container. What's a cylindrical container? It's a cylinder, y'all. Okay, not for nothing. I'm sure I got something down here. Yeah. All right? There's a cylindrical container, a little bit of tomato sauce right there. Hey, Joey, I need to minimize the surface area of this container of sauce, okay? So if we actually have a cylinder, all right, here's a little cylinder action right here. Looks a little bit like this. It's actually a cylinder with an open top, so you could draw like a little line right there to show that as an open top. The problem is people are like, how am I going to actually, minimize the surface area? Well, the thing is, the surface area of a cylinder, you want to take apart the cylinder, okay? And the top and the bottom are both circles, even though in this case it's an open top, okay? So really, this bottom right here is going to be a circle with a radius, right? You could have your radius right here, and this is actually your height, right, of the cylinder. Okay, so I know this is my radius. Normally I'd have two circles, okay, but there's only a circle on the bottom here. It's open top. What you have to understand is that this right here, okay, this portion of the cylinder, the thickness of it, it's just a rectangle, okay? I don't know if I can ruin this can of sauce right here. If this thing is going to rip off appropriately right here, it's probably going to tear into 100 pieces. So I just want to be careful here. It's already starting to rip. Of course, I have to pick the one can where it's like impossible to actually, that cans all the time in the pantry, like, the sides just fall off of them. You're like, what's in this can? It's like mystery meat, right? You open it up, you don't know what the heck it's going to be. Of course, that's obviously not happening with this can right here. Well, the idea is this, okay? If I actually, took this thing off, okay, and opened it up, if I unwrap the can, sometimes I show it this way in class, okay? We got this thing right here. So here's that cylinder, right? You can see I have this thing wrapped up. Here's my bottom. The top is going to be open. If I unwrap it, this thing actually just becomes a big rectangle here, okay? And that's the idea, okay? You're just going to end up having a rectangle. That's what's going to happen if you unwrap this piece right here. All right, so we're going to have a rectangle here. Then people struggle with, what are the dimensions, okay? Well, the dimension of the rectangle, remember, this right here, that's going to be the height of the rectangle. That's going to be this distance right here, so that's our height. What is the length? Well, when you actually unwrap this thing, okay, remember, this wrap, it wraps all the way around, right, 360 degrees. It's actually the circumference of this circle right here, okay? If you unwrap that circle, this would just become a straight line, okay? And that's what's going on. Once again, if you want to see it this way, okay, here's my circle at the top, right? That open circle right there. And you can see when I actually unwrap it, the length of that rectangle right there is going to be the circumference of the circle that we unwrapped, okay? Not so easy to use manipulatives here on a YouTube video, but I'm trying my best, okay? And remember, the circumference of a circle, I don't know if you remember, circumference of a circle is 2 pi r. That's what this distance right here is. If that bothers you, don't freak out, okay? You did it in Common Core geometry, I believe. It's not something you really see in calculus for the most part anyway, but you never know when you're gonna, be confronted with shapes like this in the real world. So you have to be able to deal with these types of things. So if you actually want the surface area, you want to get the area of each of these pieces. The area of a circle, pi r squared. And the area of a rectangle, just do base times height. So 2 pi r times h. So 2 pi r h. And the surface area is just those added together, okay? It's pi r squared. Normally it'd be 2 pi r squared because there'd be a circle top and bottom, but it's only on the bottom in this case. And then plus 2 pi r h. That's usually what bothers people the most, by the way, surface area here. Afterward, should be pretty easy to deal with. They tell you the volume is 64 pi cubic inches. You do need to know the volume of a cylinder, pi r squared h. Something which we'll use next topic when we do related rates. You see it on the AP exam. A lot of times they give you the formula. It's not as well known as it used to be, but we used to have to memorize this. They tell me the volume has to be 64 pi. I don't know why I'm doing all red marker. I got to switch up after this. You could actually divide by pi on both sides, slice the pi on both sides. I think that's funny. Slice the pi, and you get 64 equals r squared h. You could solve for r. You could solve for h. It's a calculator solution, so it doesn't matter how disgusting this thing is. But I think you're crazy. Estoy loco. If you don't actually solve for h here. Story loco. I don't even know if that's right. Loco, I know, is crazy. Sta loco. Anyway, so here I'll solve for h. It's a lot easier than having to take a square root and you solve for r. Let's go back to the black pen over here. So now our surface area is going to be in one variable. Leave that pi r squared right there. Also, if you solve for r, you got to sub it in 2 spots here, which is kind of annoying. I'll leave the 2 pi r. Take out the h, replace it with 64 over r squared. And then a little cancellation across the nation. We got surface area equals pi r squared plus cancel this r right here with one of these r's downstairs. And that gives me what? 2 pi times 64, so 128 pi divided by r. Okay, that's what it's looking like right there. So hopefully not too terrible of a situation when you simplify this thing. I mean, really, you don't even need to simplify it when you put it in the calculator anyway. You could just leave it like this. Okay, but let's go this place and get a domain. And once again, if you pick the simplest domain that r has to be greater than 0, got to be in terms of r, right? Then that's the correct domain. H can't equal 0, only a fraction with a numerator equal to 0 can equal 0, so h can really only get infinitely close to 0. Anyway, you could imagine taking the derivative of something like this and how annoying it would be, okay? But we're not doing that. It's a calculator solution, so we want to graph it. Horizontal axis is going to be the r-axis, vertical axis is going to be the SA axis, and I want to know the minimum surface area, okay?